wireless radio guys are starting to go with wireless communication. And he makes one brilliant decision. He says, you know, if they can send radio waves through space, he said, why can't I send power through space? And he launched his whole rest of his career of trying to develop a system for transmitting power without wires. That's what these are, called Tesla coils. He understood a couple things. From the radio guys, he understood that he had to get the frequency up very high for his alternating current, because the higher the frequency, the better it propagates through the air. And the other thing he realized, he had to get voltage up high enough to get it to travel without the wire. So that's basically what this device is. This device here, this one we got in about 6 months ago. A fellow donated it to us. We're plugging it into 120 volts. That 120 volts goes to a transformer down at the base that steps it up to about 12,000 volts. That 12,000 volts is put into these plates. They're just sandwiched, 2 metal plates with glass in between, which makes them a capacitor. Okay. What that does is when the energy is put across the capacitor, the plates charge up with a charge, and when they get high enough, and back here we have a spark gap, a little gap between 2 wires, and what happens is they discharge. So what happens is a very rapid charge-discharge rate, and that's what he was using to get a higher frequency. He then takes that frequency and puts it into these windings, which are primary to a transformer coil, which induces electricity into this one. Now, the voltage out of the transformer is the ratio between the input and the output. As you can see, there's very few of these, and many of these. This is copper wound wire. It's got a lacquer coating on it, so the electrons are forced to go through the wire. And this wire terminates here. So what happens is you get all this energy put it together, and it escapes out the top where there's no wires. So I'll fire this one up first, then I'll show you this one. This one, I'll warn you, the head is a little bit noisy because that spark across the spark gap puts out a bit of noise. Okay? And the other thing, you don't want to come close to it and touch it. I can kind of excite it with this ball, but some of these, I'll show you this one we can touch, but this one has a bit of a bite to it. So, all right, here we go. Let's see what happens. Here we go. I'll tell you a little story. When I first got this in this summer, I was given a tour in shorts, and I had a big wad of keys in my pocket over here. I had it a little bit closer this way, and I went in to unplug it, and my keys touched this cabinet. I got a hole burned in my leg. It induced electricity into the cabinet, charged the cabinet up, and I touched the cabinet, so I learned to be very careful. That's what he was thinking, was he would then have another coil similar to this that would get induced with the electricity and receive the electricity. Matter of fact, when I run this one, there's electricity being induced in here. When I run this one, it's being induced in here. So he was onto something. But the problem was, when he gets all this energy concentrated to this point, then he's dissipating at 360 degrees. So he's got all this energy focused, and then he loses it.
So it costs a lot to build things like this. In fact, when you're talking about money and earning money and how to make money, they must have lost a lot of hours and a lot of material.
He had some big money backers. You have to understand, Tesla was an inventor already established. He invented the induction motor, which is the same motor that's in all of our electrical appliances today. He had already built a lot of fame on that. He was a very famous worldwide inventor.
So he was the one with the whirlpool, which is going into appliances?
Basically, yeah. I mean, most all of our induction motors today is a Tesla motor. He was already into power generation too. If you've been up to Niagara Falls, the power station in Niagara Falls was a Tesla. He put that together. In fact, they have a statue up there of Tesla because he built that and he put that whole power plant together. Yep.
With a break in a wire over here, that doesn't interfere with
No, it's not a break. It's been patched. It's still continuous all the way through. So yeah, it's been fixed.
Does that copper act like windings?
No, they're all windings, individual windings. So yeah, the thing is, like I said, it's a ratio between these.
So it's not plate, it's windings.
No, it's windings. It's very, very fine wiring.
Wow.
And they're right where that breakage, you can see it's a little, very, very fine.
So it's like a step up of transformers, really, like.
Exactly, that's what this is a transformer, yeah, but a high-frequency transformer. Okay. This one I don't touch or anything because because the frequency is not real high with these plates, it really has a bite to it. As I said, I got bit and link. But this one over here, this one was built back in 1959 using a little bit different technique for the high frequency. We're using two vacuum tubes. They're high-speed switching vacuum tubes. So what's happening, one vacuum tube is turning on and off like this. And what we've done is put them in a push-pull arrangement, so when one's on, the other one's off. That doubles the frequency. Okay? If you take both impulses and put them out the same output, you now have twice the frequency. So this one has a much higher frequency. And there's the spark. Now, his idea was to transmit power through space. He was on his phone. No wires up my arm. I should wear short sleeves every time I do it. There it is. There's enough of an energy coming out of this to excite the fluorescence in a fluorescent bulb. Okay. So he was on to something. The problem was, again, that all that energy is concentrated is now being dissipated 360 degrees. He needed to focus it, and that's what he did in his later years to get another fluorescent tube there. The light time, you can't see it too well, but you can see it lighting up. It's lighting up to my hand and stopping. That kind of tells you something about where that electricity is going. Well, the thing is, the frequency is high enough, we get what we call a skin effect, which means that the electricity is traveling over the surface of the body, not through my body. I can't do that with this one. The frequency is not high enough. This one hurts. But this one, you barely get it. Feel it. So that's about 75,000 volts. There's very little amperage too. That's the other thing. The amperage has dropped to next to nothing. But yeah, he had. I think I started to say he had some backing. Carnegie. That's where he got his money. You were asking about money. He started out in Colorado Springs, Colorado, doing these experiments. Set up a fairly large one of these and fired it up one day, and he blew out the whole electrical grid of Colorado Springs, Colorado. They thought he was really cool up until that point, and after that point they said, why don't you hit the road? And he came back east. He set up right down on Long Island, and with the backing of Carnegie, was building a 6-story tall one of these. And he fired it up. He got it far enough along, so he fired it up once or twice. Carnegie got bored and said, that's it, he pulled his money. So Tesla went bankrupt. He spent his later years as a recluse living in a hotel room in New York City, working on trying to figure out how he can concentrate this energy that he's got into his beam so he could beam it from the transmitter to a receiver. Now he's thinking for peaceful power generation purposes. Other people are thinking, wow, that'd be one heck of a weapon. So when he passed away in the late 50s, when they found him, all of his files had been ransacked and stolen. It's still kind of a mystery today as to what happened to Tesla's later research. But very interesting story. He was definitely a man ahead of his time and had some very, very interesting ideas. One other thing I can demonstrate to you on this too, I've created a little whirligig that sits on top of the pin up there. If you notice, the point on this side points that way and this one points this way. The electrons, when you build them up, they usually discharge off of sharp points. In airplanes, when you're traveling at night and you're up at 35,000 feet, a lot of times static will build up on a plane, and sometimes you can see static discharge going off the points of the wings. It's called St. Elmo's fire, but it's just a static discharge. So what's going to happen, electrons are going to discharge out of here and discharge out of here, causing this whirligig to spin in the other direction. So what you're going to witness is electron beam propulsion. The space industry has been playing around with this for years because they said, gee, once they get that spacecraft up in space, there's no resistance. So simply shooting a few electrons off the back of the spaceship should make the spaceship move in the other direction. And been able to pull it off it. But you're going to be a few people that witness electron beam propulsion. In the form of a whirligig.
So much about this air around us, isn't it? Full of all kinds of stuff.
Yeah. It was something to get excited about, and it puts out a lot better sparks. And that's Tesla. Interesting sidelight, but he came up with a lot of the early techniques and concepts that the radio guys used. So he had a big piece in radio development, communications development, even though he spent his whole life